Good morning, good afternoon, and good evening to everyone joining us from around the world. I would like to welcome you to the SC21 Awards Ceremony. I'm Liz Jessup, this year's awards chair, and I'm joined by Vice Chairs Christine Quickie and Bill Gropp to co-lead the ceremony. Awards play an important role in the SC Conference Series. They celebrate great ideas and innovations in high-performance computing. The selection of the finalists and winners follow a careful and thorough process involving many members of the SC Program Committee. Awards are not just plaques or certificates, they define excellence. They set the standard for future work. They inspire both young and senior researchers to do their best. Being an award finalist at SC21 is already an achievement, and all of our nominees should be very proud. Winning an SC award is truly exceptional and is an impressive career highlight. And now for more on the awards, please welcome SC21 Technical Program Chair and Vice Chair, Mary Hall and Todd Gamblin.
Thank you, Liz. The technical program has been a central component of SC since its inception. This year, Todd and I have had the honor to serve as the conference's technical program chair and vice chair. From the beginning, the technical program has been a community event. Its success and growth depend on the collaborative contributions from thousands of participants from every corner of the world, from industry, academia, and government agencies. This year's no different. I could not be more grateful to the members of the SC21 Technical Program Committee. They committed countless hours of personal time and brought their talent and expertise to bear on an expansive slate of submissions. And this is particularly impressive given the pressures on our personal lives and work-life balance that's been imposed by the pandemic. Thanks also to our amazing community whose high-quality submissions enable SC to offer a strong and vibrant technical program year after year. And finally, my thanks to SC and the SC21 leadership for making the first hybrid SC conference possible. This has been a particularly difficult year with global uncertainty looming over every aspect of our conference planning. The SC team has worked tirelessly to ensure a safe conference environment and to accommodate those who cannot be here in person. Many of the changes have made SC more accessible to its attendees, and we hope that this year is a first step towards even more vibrant SC conferences in the future. We continue to provide an expansive view of HPC ecosystems, both current and well into the future. Through posters, papers, presentations, workshops, tutorials, panels, and birds of a feather discussions, our program explores the latest and most innovative work in algorithms, applications, architectures and networks, clouds and distributed computing, data analytics, visualization and storage, machine learning and HPC, performance, programming systems, state of the practice, and system software. For SC21, we've taken two major steps to emphasize the importance of reproducibility. First, we introduced new artifact badges for papers, and we saw impressively high participation among paper authors. We've also introduced a new Best Reproducibility Advancement Award for papers aimed at incentivizing authors to address the unique reproducibility challenges of HPC with new tools and techniques. We thank our reproducibility chairs, without whose initiative and tenacity these developments would not have been possible. We're also proud to support SC21 inclusion efforts. We've worked hard to ensure that we have a diverse representation of gender, race, ethnicity, geography, experience, and institutional affiliation across the program committee. To ensure that SC remains a welcoming environment for all participants, we've worked with SIGHPC this year to establish for the first time a SIGHPC Cares Committee that's been here at SC21. So CARES is a resource for those who experience discrimination or harassment in violation of ACM's policies governing SIG activities. CARES supports these individuals by allowing them to work with established members of the SC community who are approachable and willing to listen and help navigate the reporting and accountability process. Within technical papers, we've retained the double-blind review process and allowed authors to submit revisions to accepted papers, leading to a higher overall quality of the technical papers. And to the benefit of the whole community, SC21 has worked with IEEE and SIGHPC to continue to make all of our proceedings freely and easily available through OpenTOC. I'd like to thank all of you for bringing your ideas, innovations, and research to this conference. Your work is transformational and is having a significant impact on major societal challenges, as we've seen this week. As Liz said, this year's awards speak to the excellence in our community. Let's give a round of applause to all who've contributed to the SC21 technical program.
The Technical Program Committee is composed of roughly 600 volunteers who spent many hours reviewing and selecting the winners. Without a doubt, they had some very tough decisions to make. And then there was a tremendous effort to organize the actual events at the conference. On Tuesday, we announced the ACM and the IEEE Computer Society Awards. Dr. David Abramson of the University of Queensland is recognized for the Ken Kennedy Award for outstanding achievements both in software research and in mentoring or other service activities. Dr. Abramson is recognized for innovation in parallel and distributed computing tools with broad applications, as well as leadership contributions to professional service, creating international technical communities and mentoring. Professor David Bader from the New Jersey Institute of Technology received the Signe Fernbach Award for outstanding contributions in the application of high-performance computers using innovative approaches. Professor Bader is recognized for the development of Linux-based massively parallel production computers and for pioneering contributions to scalable discrete parallel algorithms for real-world applications. Congratulations to our awardees. In this ceremony, we present awards for nearly all of the technical program areas, as well as components of our Students at SC program. We seek to recognize excellence above and beyond with an emphasis on those contributions that we believe will have long-lasting impacts on our community's work. Thank you for all your participation in this novel and hopefully unique SC. Now I'll turn it over to the awards chair, Liz Jessup, to begin the awards presentations. Thanks.
Thank you, Todd and Mary. Let's begin with our first awards category of the day. The Student Cluster Competition, now in its 15th year, features 2 awards. The first award is for the team that achieved the highest LINPACK performance, and the second award honors the overall winning team. The Student Cluster Competition showcases students' skills in a friendly, yet spirited 48-hour nonstop competition that tests students' abilities to optimize the use of HPC resources in a constrained environment to run a series of science applications. Traditionally, the students partner with vendors to design and build a cutting-edge cluster from commercially available components and work with application experts to tune and run the competition codes under a 3,000-watt power budget for their cluster. This year, the teams competed while running on both Azure Cloud from Microsoft and Oracle Cloud, working with 2 different types of constraints. On Azure Cloud, teams were constrained by a budget that was provided by Microsoft. They managed the budget to choose what hardware configurations to run on. On Oracle Cloud, teams were constrained by preset hardware, but no budget to manage. The student competition is supported by Oracle, Microsoft, and ARM. Highlights are available at studentclustercompetition.us. To present this year's winners, please welcome the SC21 Students at SC Chair, Jay Lofsted. Throughout this ceremony, winners should come up the ramp to the stage that is on that side over there. It's called stage left, but it is on your right. A student volunteer will help to direct you.
Thank you. The 2021 teams participating in the Student Cluster Competition are shown on this slide. As you can see, we have a large number of teams here from the United States and from China. And now it's time to announce the winners. As our SCC teams participated remotely, they will not be able to join us on stage, but we welcome your applause after we've announced these 2 awards. That way they can get it in the video or in the live stream. The winner of the SC21 Student Cluster Competition for the highest LINPACK benchmark is the SUSTEC computing team from Southern University of Science and Technology in Shenzhen, China. The overall student cluster competition winner was determined based on a combined score for correctly completed workloads, benchmark performance, and demonstrated understanding of architecture and performance through profiling and analysis, interviews, and their poster presentation. The overall winner of the SC21 student cluster competition is the Tsinghua University team from Beijing, China. So our 2 winning teams, again, are not here today, but please join me again in congratulating them.
Good. Thank you, Jay. The Technical Papers program is one of SC's most valued components. Each year, we receive submissions of original research that introduces new ideas to the field and stimulates the future trends in high-performance computing. Just like previous conference years, the competition for SC21 was high, with 361 papers submitted covering a wide range of research interests and topics. The Technical Program Committee met virtually for 2 days in June to review the papers. At the conclusion of the meeting, the committee accepted 99 papers, representing a 27% acceptance rate. Of the 99 papers, 10 have been selected as finalists for the Best Paper and Best Student Paper awards. And now to present the Best Student Paper and Best Paper awards, please welcome David Abramson, Chair of Technical Papers.
Thanks, Liz. This year we had 2 finalists that were nominated both as Best Paper and Best Student Paper. The nominees are Enabling and Scaling the HPCG benchmark on Sunway Ocean Light with 28 million heterogeneous cores, CUTS, Scaling Subgraph Isomorphism on Distributed Multi-GPU Systems using Tri-based Data Structures. 5 additional finalists were nominated for Best Paper Award. These nominees are SEEK, Stochastic Escape Express Channel, Chimera, Efficiently Training Large-Scale Neural Networks with Bidirectional Pipelines, Revealing Power, Energy, and Thermal Dynamics of a 2,000 petaflop pre-exascale supercomputer, Accelerating large-scale de novo metagenome assembly using GPUs, Understanding, Predicting, and Scheduling serverless workloads under Gray inference. And 3 additional finalists were nominated for Best Student Paper Awards. These nominees are Evan, a scalable node ground truth file system for massively parallel computing, reverse mode automatic differentiation and optimization of GPU kernels via Enzyme, and efficient large-scale language model training on GPU clusters. The SC21 Best Student Paper Award goes to Efficient Large-Scale Language Model Training on GPU Cluster by a team from Stanford, NVIDIA Corporation, and Microsoft. The winners are not present, so let's celebrate their accomplishments with applaud, which we just did. And now the SC21 Best Paper Award goes to Revealing Power, Energy, and Thermal Dynamics of a 200 petaflop pre-exascale supercomputer by a team from Oak Ridge National Laboratory. And these winners are also not able to attend the conference. Thanks, Liz.
Thank you, David. We now turn our attention to honoring a paper from a past SC conference whose impact on the field continues long after the paper first appeared. David Keyes, who is chair of the SC21 Fernbach Award Committee, will speak in place of Test of Time Award Chair David Bailey, who was not able to attend the conference.
The SC21 Test of Time Award honors a paper that appeared at SC between the years 1996 and 2011. The Test of Time Award recognizes an outstanding paper that has deeply influenced the HPC discipline. It is a mark of historical impact and recognition that the paper has changed HPC trends. This year's award goes to a paper published at SC98. Please welcome to the stage the authors of the paper. Multi-Level Algorithms for Multi-Constraint Graph Partitioning by George Karipis and Vipin Kumar. This paper presents efficient and effective multi-level algorithms for multi-constraint graph partitioning. The algorithms that the authors develop in this paper were incorporated into the METIS and PAR-METIS graph partitioning software packages, which are used extensively to enable the efficient parallel execution of complex scientific computations. These tools have been used in a variety of HPC applications, ranging from semiconductor design and designing electoral districts to partitioning the computational graphs of large deep learning models. Overall, the paper has had a major impact on the field and is destined to have a continuing impact for years to come.
To lead our next award segment, please join me in welcoming to the stage the 2022 IEEE Computer Society President and SC21 Awards Vice Chair, Bill Gropp.
Thank you, Liz. Our next award segment features the posters competition, which includes the research posters and the ACM student research competition. These posters showcase some of the most cutting-edge research in high-performance computing, networking, storage, and analytics. This year, there were 71 submissions that went through a rigorous review process. We would like to thank the reviewers for their hard work in evaluating these high-quality submissions. In the end, 45 posters were accepted, with 3 finalists selected for the Best Poster Award, and 3 finalists were selected to participate in the ACM Student Research Competition. Now, to present the Best Poster Award, please welcome the SC21 Posters Chair, Boyana Norris.
Thank you, Bill. I am glad to be here. The poster session is an important activity where the poster authors and all SC participants enjoy face-to-face discussions on their research. We congratulate all poster authors on persevering during continued uncertainty and helping to make this hybrid SC conference a success. For many authors, this is their first contact with SC, and for some of them, this will be their first, and hopefully not last, award. This year's finalists are Code Generation and Optimization for Deep Learning Computations on GPUs via Multidimensional Homomorphisms, Open Source high-performance computing for applications in engineering, DEM vehicle simulations with Project Chrono, FPGA accelerated ripples, and the SC21 Best Research Poster Award goes to Enabling Combustion Science Simulations for Future Exascale Machines. The first author is John Rood. This work is an impressive combination of a high-impact application and strong scaling results on multiple supercomputers. The winners could not attend in person, so let's congratulate them all with applause. As part of its research poster activities, SC21 also hosted the ACM Student Research Competition. It enables undergraduate and graduate students to experience the research world, share results, and exchange ideas. In the end, 23 student research competition posters were accepted, 12 in the graduate category and 11 in the undergraduate category. Today's first place winners will move on to ACM Student Research Competition Grand Finals next year. And now, we are honored to announce the winners of this year's ACM Student Research Competition. We'll start with the undergraduate level awards. The SC21 undergraduate third place winner is Regulating Traffic in a Crowded Cache, Overcoming the Container Explosion Problem by Kevin Gao at the University of California, Berkeley. The SC21 undergraduate second place winner is Delving into the Abyss, a distributed decompression system for indexing compressed repositories by Ryan Wong at Northwestern University. And the SC21 undergraduate first place winner is Data Store Design for Analysis of Police Broadcast Audio at Scale by Aya Ahmad at the University of California, Berkeley. The winners could not attend in person, but please join me in applause one more time. And now for the graduate level awards. The SC21 graduate third place winner is QSZ Plus, Optimizing Error-Bounded Lossy Compression for Scientific Data on Modern GPUs by Jan Nantian, Washington State University. The SC21 graduate second place winner is Parallel Algorithms and Frameworks for Learning Large-Scale Bayesian Networks by Ankit Shrivastava, Georgia Institute of Technology. And the SC21 graduate first place winner is Missing the Trees for the Branches, Graphical Scripting Interaction with Large-Scale Calling Context Trees by Connor F. Scully Allison, University of Arizona. Winners. Congratulations to all.
Thank you, Bojana. This is the 8th year of the Scientific Visualization and Data Analytics Showcase. 5 finalists competed for the award this year and presented their videos during a dedicated session. Videos are judged based on overall quality, how they illuminate science, and on creative innovations in the production process. Now, to present the Best Visualization Award, please welcome SC18 General Chair and SC21 Awards Virtual Logistics Liaison, Ralph McEldowney, who is representing Chair Elaine Rayborn.
Thank you, Bill. It is my pleasure to share these honors with the finalists and winners today. First, I would like to thank all those teams that submitted to the Visualization Showcase. This year's finalists created impactful visualizations using innovative visual elements. I thank the Showcase Committee members for completing the difficult task of reviewing the submissions and selecting both the finalists and the best overall visualization. At this time, on behalf of the entire Visualization Showcase Committee, I'm pleased to announce the finalists of the Best Visualization Award for the SC21 Scientific Visualization and Data Analytics Showcase. This year's finalists in alphabetical order are Polly Enyas, Polar Physics Revealed through Visualization of the E3SM Global Climate Model. Putting the Ocean into the Center, a coupled icon atmosphere ocean simulation in Spillhouse projection. Visualization of an above anvil cirrus plume. Visualization of human scale blood flow simulation using Intel OSP Ray Studio on Super MUC-NG. Visualization of a neutron star binary merger and subsequent creation of a kilonova. And visualizing a particle-based simulation of an aggregate drum dryer for hot mix asphalt production. And the SC21 Best Visualization Award goes to Putting the Ocean into the Center, a coupled icon atmosphere ocean simulation in Spillhouse projection by a team from the German Climate Computing Center, the Max Planck Institute for Meteorology, Stockholm University, and the Intel Corporation. Our winners are not with us today, but let's congratulate them once more.
Thank you, Ralph. The IEEE Computer Society's Technical Consortium on High-Performance Computing has an Early Career Researchers Award for excellence in high-performance computing. This award recognizes up to 3 individuals who have made outstanding, influential, and potentially long-lasting contributions in the field of high-performance computing within 5 years of receiving their PhD. I will present this award in place of Vladimir Getov, who is the chair of the award committee but cannot attend this conference. I am very pleased and honored to announce the 3 winners of the 2021 IEEE-CS TCHPC Award for Excellence in High-Performance Computing. The recipients of this award receive a plaque and are recognized by IEEE Computer Society's TCHPC and its member technical committees' websites, newsletters, and archives. In addition, they receive complimentary IEEE-CS membership for 1 year. The winners of this year's TCHPC Early Career Researchers Award for Excellence in High-Performance Computing are Dr. Bing Zhi. Dr. Zhi is a research scientist at Oak Ridge National Laboratory. She received her PhD in computer science from Duke University in 2017. Dr. Zhi conducts computer systems research with a strong publication record spanning multiple research areas, including large-scale parallel file systems, deep learning systems, and resource management. Her improvements to HDF5, a widely used HPC I/O library, were successfully used for performance tuning of the Summit supercomputer at the Oak Ridge Leadership Computing Facility. Next recipient is Dr. Yang Yu. Dr. Yu is a Presidential Young Professor at the National University of Singapore. He received his PhD from UC Berkeley. The focus of his current research is efficient deep learning on distributed systems. In 2017, his team broke the world record of ImageNet training speed. In 2019, his team broke the world record of BERT training speed. Dr. Yu's training techniques have been used by many tech giants, such as Google, Microsoft, and NVIDIA. His LARS and LAM optimizers are available in the industry benchmark MLPerf. And our third recipient is Dr. Emily Chi Zhu. Dr. Zhu is an assistant professor at the College of Computer Science and Software Engineering, Shenzhen University. She received her PhD in computer science from Nanyang Technological University in 2016. From May 2016 to August 2017, she was a postdoctoral fellow at INRIA Rennes in France. Emily has been working on the convergence between HPC and big data, with a special focus on the resource optimizations for efficient and scalable data management in large-scale parallel and distributed systems. Our winners are not present today, but please join me in applause to celebrate their accomplishments. The ACM IEEE Computer Society's George Michael Memorial HPC Fellowship honors exceptional PhD students in our field. This fellowship is very meaningful to SC, as it is named after the very first SC Conference General Chair, George Michael. Dr. Michael was the SC General Chair in 1988. These fellowships are sponsored by ACM and the IEEE Computer Society and include a $5,000 honorarium. To present the awards, please welcome a member of this year's George Michael Memorial HPC Fellowship Selection Committee, Jack Dungara.
Thanks, Bill. And thank you for the opportunity to present this award. And it's with great honor that I announce the 2021 George Michael Memorial HPC Fellowship winners. This year we had 12 nominations for the fellowship from universities around the world, and we have 2 winners. When I announce your names, please join me on stage on the left here. Our first 2021 winner is Merck Haideyutuglo from the University of Illinois at Urbana-Champaign for his contributions in scalable sparse applications using fast algorithms and hierarchically communication on supercomputers with multiple GPUs. Our second winner is Turik Patel from Northeastern University for his contributions towards helping HPC programmers solve computationally challenging problems and for making the current error-prone quantum computing systems more usable. Please join me up on stage, guys.
Okay. All right. Okay. I'm cheating up here. We've got a teleprompter. Okay. As we continue, please join me in welcoming to the stage SC20 General Chair and SC21 Awards Vice Chair, Christine Quickie.
Good afternoon. And now on to the ACM Gordon Bell Prize, established in 1987, which is awarded for outstanding team performance and achievement in high-performance computing. The purpose of this award is to track the progress of parallel computing over time, with particular emphasis on rewarding innovation and applying high-performance computing to applications in science, engineering, and large-scale data analytics. In addition, we will honor an ACM Gordon Bell Special Prize, which focuses on HPC-based COVID-19 research. This award recognizes outstanding research achievements toward the understanding of the COVID-19 pandemic through the use of HPC, with a particular focus on innovations in parallel computing. This work is incredibly important as we work towards solutions to this global crisis impacting us all. The winning teams for each prize receive a $10,000 award. To announce the finalists for both awards, please welcome the chair of this year's Gordon Bell Prize Selection Committee, Mark Parsons.
Thanks, Christine. The 6 finalists for the ACM Gordon Bell Prize were chosen on the basis of their application's performance, the significance of their work, and the level of innovation demonstrated through their papers, as well as recommendation letters to assess the impact of the results in both HPC and the scientific, engineering, or large-scale data analytics domain they focus on. The first finalist paper is Anton 3, 20 microseconds of molecular dynamics simulation before lunch. The second finalist paper is Symplectic Structure-Preserving Particle-in-Cell Whole Volume Simulation of Tokamak plasmas to 111 trillion particles and 25.7 billion grids. The third finalist paper is Closing the Quantum Supremacy Gap, Achieving Real-Time Simulation of a Random Quantum Circuit Using a New Sunway Supercomputer. The fourth finalist paper is Billion Atom Molecular Dynamics Simulations of Carbon at Extreme Conditions and Experimental Time and Length Scales. The fifth finalist paper is a 400 trillion grid Vlasov simulation on Fugaku supercomputer, large-scale distribution of cosmic relic neutrinos in a 6-dimensional phase space. The sixth finalist paper is Extreme-Scale Ab initio Quantum Raman Spectra Simulations on the Leadership HPC system in China. These teams presented their work in sessions over the last 2 days, and it was great to have so many strong submissions this year. I'm honored to present the ACM Gordon Bell Prize today. The selection committee went through extensive deliberations to decide the winner. And the winner is Closing the Quantum Supremacy Gap, Achieving Real-Time Simulation of a Random Quantum Circuit Using a New Sunway Supercomputer by Yong Liu, Xin Liu, Fang Li, He Huanfu, Yulan Yang, Jaiwei Song, Peng Peng Zhao, Zhen Wang, Dajia Peng, Hurong Chen, Chu Guo, Hailiang Huang, Wenzhao Wu, and Dexun Chen. The winning research brings together the worlds of supercomputing and quantum computing. It demonstrates outstanding levels of performance on the new Sunway supercomputer at China's National Supercomputing Center in Wuxi. The paper challenges Google's quantum supremacy declaration in 2019 through the development of a highly efficient random quantum circuit simulator on the new Chinese exascale system. Unfortunately, our winners cannot be with us today in St. Louis, but many congratulations to the whole team. Next, we present the ACM Gordon Bell Special Prize in high-performance computing-based COVID-19 research. The 6 finalists for the ACM Gordon Bell Special Prize were chosen on the basis of their practical contributions towards understanding the nature, spread, and/or treatment of the disease, in addition to the innovation, significance, and performance demonstrated through their use of HPC, and more importantly, addressing the pandemic. The first finalist paper is Digital Transformation of Droplet Aerosol Infection Risk Assessment Realized on Fugaku for the Fight Against COVID-19. The second finalist paper is Language Models for the Prediction of SARS-CoV-2 Inhibitors. The third finalist paper is Data-Driven Scalable Pipeline Using National Agent-Based Models for Real-Time Pandemic Response and Decision Support. The fourth finalist paper is #COVID is Airborne, AI-enabled multi-scale computational microscopy of Delta SARS-CoV-2 in a respiratory aerosol. The fifth finalist paper is FEP-based large-scale virtual screening for effective drug discovery against COVID-19. The sixth finalist paper is Intelligent Resolution, Integrating Cryo-EM with AI-driven multi-resolution simulations to observe the SARS-CoV-2 replication transcription machinery in action. The committee felt that all of these papers were of very high quality, and the teams presented their work in sessions over the last 2 days. HPC has played a major part in understanding the SARS-CoV-2 virus, and I know many people across our community have contributed to many different projects which were established at great speed. I'm honored to present the ACM Gordon Bell Special Prize in High-Performance Computing-Based COVID-19 Research today. When I announce the winning paper and team, members who are here today, please make your way to the stage. And the winner is Digital Transformation of Droplet Aerosol Infection Risk Assessment Realized on Fugaku for the Fight Against COVID-19 by Kazuto Ando, Rahul Bale, Chunggang Lee, Satoshi Matsuoka, Keiji Onishi, and Makoto Tsubokura. The winning research took experience of an existing industrial modeling code and applied it on Fugaku, using an ensemble approach to understand droplet and aerosol spread from people with COVID-19. What particularly impressed the committee was that this work changed public behavior in Japan and internationally in the early stages of the pandemic.
Thank you, Mark. Our next three recognitions are sponsored by ACM's SIGHPC. The first is a certificate of appreciation related to the Reproducibility initiative used in this year's student cluster competition. The second is the ACM SIGHPC Computational and Data Science Fellowships, created to increase the participation of underrepresented graduate students in computational and data science. The third is the ACM SIGHPC Outstanding Doctoral Dissertation Award, which was created to recognize the best doctoral dissertation completed in high-performance computing in the last year. To present these awards on behalf of ACM SIGHPC Chair John West, please welcome the ACM SIGHPC Past Chair and SC12 General Chair, Jeff Hollingsworth.
Thank you, Christine. I'm pleased to be here to present the ACM SIGHPC Certificate of Appreciation, which is presented to the authors of a recent SC paper selected to be used in the SC21 Student Cluster Competition Reproducibility Initiative. The paper being honored was selected from the papers presented at SC20 in the applications category. Will the authors who are present please join me on stage? The selected paper is a parallel framework for constraint-based Bayesian network learning via Markov blanket discovery. The authors are Ankit Srinivasa, Siram Chakaliham, Srinivas Arua. The team of reviewers selected this paper from a pool of finalists based on the paper's excellent artifact description and its suitability for the cluster competition. Congratulations. The ACM SIGHPC Computational and Data Science Fellowship Program was created to increase participation of underrepresented groups, women, students, and those with diverse racial and ethnic backgrounds in computational and data science graduate programs worldwide. The fellowship, first awarded at SC15, includes a stipend of $15,000 annually during their graduate studies. I'm honored today to present the ACM SIGHPC Computational and Data Science Fellowships. When I announce the winner, Would those who are present here please make your way to the stage? Please hold your applause until we've read all the names of the recipients. And the winners are Osana Osawata, University of Ibadan; Somaya Ramazina, Mississippi State University; Kiana Burton, University of Colorado Boulder; Monique Hooley, University of California, Berkeley; Chinea Ifemberanaki, North Carolina A&T State University; Daniela Marcazai, University of Illinois Urbana-Champaign; Ismael Mendoza, University of Michigan; Lauren Oy, University of California, San Diego; Ana Arena Realeniu, École Polytechnique Federale de Lausanne; Harry Rees, Columbia University; Tanya Tafoya, University of California, Merced. Please join me in congratulating all 11 recipients of the 2021 ACM SIGHPC Fellows. SIGHPC's last award today is the ACM SIGHPC Outstanding Doctoral Dissertation Award. The award was established in 2018. It's open to students studying anywhere in the world who have completed a PhD dissertation with high-performance computing as a central research theme. The award recipient receives a cash prize of $2,000 and a plaque. The winner is chosen by a competitive process with a nation and international level selection board. Nominations were evaluated on technical depth, the significance of research contributions, the potential impact on theory and practice, and the overall quality of the work. For this award, HPC research refers to the study of or applications of computational capabilities delivering much higher performance or at larger scales than could be accomplished with a desktop or simple server system to solve larger problems. The committee, consistent with the award guidelines, has chosen to also recognize 2 honorable mentions this year. The first honorable mention is Dr. A.J. Lauer for her dissertation, Cyber Infrastructure Professionals Withdrawal Conditions, an exploration of race, gender, and occupational climate in high-performance computing. This research was completed at the University of Creighton. The second honorable mention is Dr. Yang Yu for his dissertation, Fast and Accurate Machine Learning on Distributed Systems and Supercomputers, completed at the University of California, Berkeley. And now, when I announce the winner of this year's award, would they please join me on stage? The winner of this year's SIGHPC Outstanding Doctoral Dissertation Award is Dr. Rohit Zombre. Dr. Zombre is recognized for his dissertation, Exascalable Communications for Modern Supercomputing. He received his PhD in computational science from the University of California, Irvine in 2020. Dr. Zombre's work analyzes the decade-long problem of slow multi-threaded communication in supercomputing applications and eliminates the communications bottleneck by bridging the 2 ends of the HPC stack, MPI library developers and domain experts. Please welcome him to the stage.
Thank you, Jeff. New for SC21 is the SC Best Reproducibility Advancement Award. This award aims to recognize outstanding efforts in improving transparency and reproducibility of methods for high-performance computing, storage, networking, and analysis. I speak today for Reproducibility Committee Chair Carlos Maltzahn and Best Reproducibility Advancement Award chairs Tanya Malik and Anho Valdiak Oberwagner, who could not be with us today. The paper or research object being honored was selected from 19 nominated technical papers accepted for SC21. In this context, a research object refers to a collection of computational artifacts that extend beyond the submitted paper, such as software, data sets, environment configuration, mechanized proofs, benchmarks, or test suites with scripts. When I announced the winners, I asked the team members who are present to please join me on stage. The winner is HPAC, Evaluating Approximate Computing Techniques on HPC Applications, with authors James D. Diffenderfer, Yorgos Georgakis, Ignacio Laguna, Harsitha Menon, Daniel Ose Kafur, Konstantinos Parasiris, and Marcus Shorten, all from Lawrence Livermore National Laboratory. A team of reviewers consisting of members from the SC21 Reproducibility Initiative and the technical paper committees selected this paper or research object for its significant advance in the state-of-the-art in transparency and reproducibility. This paper was chosen for advancing artifact design and significantly reducing reviewer time for artifact description and evaluation despite complex evaluation procedures. The following artifact features impress the reviewers. It's very easy to use. It has a simple, customizable design. It provides data sets in various sizes and formats for testing, and it reproduces all original results published in the paper. The artifact acquired all 3 badges: artifact available, artifact reproducible, and results reproduced. As we reach the end of SC21, I thank ACM, SIGHPC, the IEEE Computer Society, our committees, and all of you here today, virtually or in person. And now I'd like to invite the gentleman who's had a tougher job than I did, leading the SC21 General Planning Committee through SC21 and putting on a remarkable show. General Chair Bronislaw Samitsky, please welcome to the stage.
Thank you, Liz, Bill, Christine, and everyone who has worked to make this session and the entire SC21 conference a success. Hundreds in the HPC community have generously given of their time not only to realize this week's outstanding program, but to make the world a better place. The HPC community effort has been ongoing for many years, and I am honored to be a part of it. Thank you all.